Hi guys, welcome back to Life with YouTube channel. So we have discussed many topics now, but the last topic we have discussed is easy tricks, right? If you just keep with mind, you can understand everything in that. And then before the topic, I have discussed your row and column operations, but I have discussed only little questions, right? So some more questions we can discuss today, and the questions are. Row and column operations, right? So today's first question is, show that a plus b plus 2c c a b plus c plus 2a b c plus c plus 2b. Here the determinant of a plus b plus 2c a b c b plus c plus 2a b c a c plus a plus 2b is equal to 2 into a plus b plus c whole cube. Okay, so that is the question. Okay, so now how to find it? Okay, so therefore the solution is, just we need to find determinant. You know how to find the determinant, plus minus plus, in that way you'll find, right? But it's very complex to do in that way. So as we discussed about row and column operations, it is very easy by that method, right? So let's discuss that. Okay, so here now solution will be, first of all, now the row operation I'm doing is row 1 implies row 1 minus row 2. I mean R1 implies R1 minus R2, as well as R2 implies R2 minus R3. Okay, is this okay now? So now therefore a plus b plus 2c minus c. So a plus b plus c. And now here a minus b minus c minus 2a. Therefore minus a minus b minus c. Because a minus 2a now minus a will get. And next b minus b is 0. Here c minus c, because row 2 implies row 2 R2 minus R3. C minus c is 0. Right? B plus c plus 2a minus a plus b plus c we will get. B minus c plus a will get minus a minus b minus c. And row 3 is as it is, because we are not doing any row operation to or column operation to that. Okay, is it fine? Do you understand here everything? So now here, now you got everything, I think so. Now we can discuss next step. So therefore the next step is, now I am taking a plus b plus c out from first row. From first row I am taking a plus b plus c out, and from second row also I am taking out a plus b plus c. Therefore a plus b plus c into a plus b plus c will get a plus b plus c whole square. Here 1. A plus b plus c into minus 1 will get a minus b minus c. 0 0 1 minus 1. Here c a c plus a plus 2b. Okay, till here you have understood, I think so. So if we do next step also, we won't get that. So directly now we can find here determinant of the along the first row. So therefore the det will be a plus b plus c. Wait a minute. See here, now we are applying det along first row. So therefore a plus b plus c whole square. So I have written this as it is there, and next we have to apply here det. So therefore 1, right, 1 into c plus a plus 2b. Okay, c plus a plus 2b minus of minus a, therefore plus c. Okay, and now minus 1, minus into minus 1 we will get plus 1 into, just delete that respective row and column, then we'll get this 0. Therefore minus into minus plus c. Okay, so now a plus b plus c whole square. Here c plus a plus 2b plus a plus c. Therefore A plus A, 2A, 2B, C plus C, 2C. Okay, you have understood till that. And now A plus B plus C whole square, if I am taking out 2, therefore 2 into A plus B plus C. If I take, then 2 into A plus B plus C square into this, so it becomes cube. Okay, so we have proved this. Okay, do you understood that? Is it fine? So next, please note down that in your book. We can go to next question. Okay, note down this problem. Okay, is this okay now? So now let's go to next question. Okay, so therefore now the question is, so the next question is A, B, C, A square, B square, C square, A cube, B cube, C cube is equal to A, B, C into A minus B into B minus C into C minus A. So that is the question. Okay, determinant of A, B, C, A square, B square, C square, A cube, B cube, C cube is equal to A, B, C into A minus B into B minus C into C minus A. Okay, so therefore the answer will be, first of all, I am taking A from this row and B from this row and C from this row. Okay, therefore A, B, C, here solution. So from first column I am taking A out, and from second column B out, and from third column I am taking C out. Therefore the remaining matrix will be, if I take A from this 1, in A square if I got one A out, then it will be A, and from A cube it will go A out, then A square. So therefore 1B, B square, 1C, C square. Okay, do you understand till here? And now here, as we taken A, B, C out, just now we need to get A minus B, B minus C, C minus A. In which method if we do, we will get that we need to do now. So now I am doing column 1 implies column 1 minus column 2. Okay, column 2 implies column 2 minus column 3. Column 3 implies column 3 minus column 1. So therefore the resultant matrix will be, if I am taking ABC out, therefore column 1 minus column 2, 1 minus 1, 0, A minus B, A square minus B square. Okay, next 1 minus 1, 0, B minus C, B square minus C square, and next 1 minus 1, 0, C minus A, C square minus A square. Okay, so this is the matrix now we got. Now here, as we taken A, B, C out, now from first column I am taking A minus B out, and from second column, listen here, I am writing from first C1 I am taking A minus B, and from C2 I am taking B minus C, and from C3 I am taking C minus A. So from that our resultant matrix will be ABC into, okay, are you understanding? So ABC into A minus B into B minus C into C minus A, because these are the things we are taking from this matrix out. So therefore the remaining matrix will be this one into matrix 0, 0, 0, Here, if we take from first column a minus b, here we will get 1. If we take in this a minus b, then we will get remainder of a plus b. Because a minus b into a plus b is a square minus b square. Is it okay now? So now from second column we are taking b minus c, then we will get here b minus c, and here we will get b plus c, here 1, here c plus a. Okay. So if we find the determinant of this, we will get a b c into a minus b into b minus c into c minus c. So this is the answer. Okay. So as we said, we need to prove that. We have proved it. Okay. So next we can go to next question. Is it clear? Once again I am saying you listen here. This is the question they given and this is the need to prove that. And from first column and from second column and from third column I have taken a, b, c out. Then 1, 1, 1, a, b, c, a square, b square, c square is the remaining matrix to me. And then from C, I have applied now column operation, that is column 1 implies column 1 minus column 2, and column 2 implies column 2 minus column 3, and column 3 implies column 3 minus column 1. So therefore, I have got this the matrix. Therefore, from column 1 I have taken A minus B out, and column 2 I have taken B minus C, and column 3 I have taken C minus C out. Therefore, the remaining matrix is this. Therefore, after finding the determinant, I have got this answer. So, this is the resultant and that we have proved. Therefore, hence we proved. Okay? Understood? So, next question. So, the next question is, so now the third question is 1a square, 1b square, 1c square. We need to prove is a minus b into b minus c into c minus c. Okay? It's nothing but we need to prove that the determinant of 1a square, 1b square, 1c square is equal to a minus b into b minus c into c minus c. So therefore, the way we need to find is, first of all I am doing row operations. So the row operation is row 1 implies R1 minus R2. Okay? R1 implies R1 minus R2 and R2 implies R2 minus R3. So these are the two row operations now I am doing. So therefore, the resultant matrix will be R1 implies R1 minus R2, right? So 1 minus 1, 0. A minus B, A square minus B square, A square minus B square. 1 minus 1, 0. B minus C, right? Next B square minus C square. With this, along with this, now I am doing R3 implies R3 minus R1. Okay. Here in the first step itself, I am doing 3 row operations. Therefore, the resultant matrix will be R3 implies R3 minus R1, right? So 1 minus 1, 0, C minus A, and C square minus A square. So now, from first row, I am taking A minus B out. From second row, I am taking B minus C out. And from third row, I am taking C minus C. So for that, for explanation, I am writing. From row 1, I am taking A minus B out. From row 2, B minus C. And from row 3, C minus A. Okay. So therefore, the resultant matrix will be 0, 1, A plus B. 0, 1, B plus C. 0, 1, C plus C. So if we take those all out here, we need to write, right? So A minus B into B minus C into C minus A. So if we find here that along this column, is nothing but 0. So therefore we proved that A minus B into B minus C into C minus A. Okay, is it clear? No, as I said, one rule, there is no rule that we need to find along row only with a det along row 1. We can find the det along even column 1 also. Okay, so as I find along column 1, I get 0. So therefore the resultant answer will be A minus B into B minus C into C minus A. Hence proved. Okay, is it clear? Once again I am explaining. As I taken this matrix is equal to, we need to prove this. Okay, show that it is. So in the first step itself I have done 3 row operations. It's nothing but row 1 implies row 1 minus row 2, R2 implies R2 minus R3, R3 implies R3 minus R1. Therefore the resultant matrix is this. Okay, so as I got this, and from row 1 I have taken A minus B out, and from row 2 I have taken B minus C out, and row 3 I have taken C minus C out. Therefore the resultant matrix is this, and I have proved it. Okay, so we can go to next question. So therefore the next question is, the next question is X A X A X. Okay, and we need to show that the determinant of X X is equal to x plus 2a into x minus a square. Okay, so now I'll solve this question by row operations, that is row 1 implies R1 minus R2, R2 implies R2 minus R3. Once again I am saying one of the important thing is, while we are doing one of the operation of the one of the row, and that should be as it is here without any coefficient. Okay, so that is the important thing. Therefore after doing these row operations, the matrix will be row 1 implies row 1 minus row 2, no? So x minus a minus x, a minus a 0, a minus a 0, x minus a minus x, and row 3 we are not doing nothing, so a x. Keep it as it is. Now from row 1 and row 2 I am taking x minus a out. So therefore it becomes x minus a whole square into x minus a, if I take out 1, here x minus a means minus 1, 0, 0, 1, minus 1, and the remaining elements are a x. Okay, is it fine? So, but we need to get x plus 2a into x minus a whole square. Now I am doing that along this matrix. So therefore, as we got x minus a whole square into here. Now we need to do that along first. So therefore 1 into x plus a. Okay, x plus a. And here minus 1 into minus 1 plus 1. So if we delete this respective row and column, we'll get 0, 0 minus of minus a, we'll get plus a. So therefore x minus a whole square into x plus a, therefore x plus 2a. Okay, hence proved. Okay, once again I am showing you. First step, they have given xaa. Okay, here xaa, axa, aax. Okay, here they had told that to prove that x plus 2a into x minus a whole square. Okay, is it clear now? So after that, now the solution I have done is, first of all I have done row operations, two row operation, and that is row 1 implies row 1 minus R2. Why you have a doubt that why she is doing always row 1 implies row 2 or row 1 implies row 1 minus row 2? Because I need to just, I'm not doing in that way itself, I'm getting to know how to do that. Here I need to get x minus a and here x plus 2a. There is no way that x plus 2a to get at. So we can do x minus a, or else the thing one way is x plus 2a we need to get in this way. Row 1 implies row 1 plus row 2 plus row 3. In that way we will get x plus 2a, but it's big method. If we get x minus a, so row 1 implies row 1 minus row 2, then I'll get x minus a here, then I'll get x minus a whole square. In that way I have done row 1 minus row 2 and row 2 minus row 3. After that I have applied that along the resultant matrix, then I got x minus a whole square into x plus 2a, hence it is proved. Okay, I think you have understood this. Please, if you have any doubts, write them in the comment. And please, if you like this video, please like it and subscribe it. Thank you.